So hi everybody, thanks for coming. My name is Noel Yopes, and this presentation is going to be about using UIKit and OpenGL. Actually, before that I should say, this time slot we're going to have two presentations. We're going to have my presentation, and then Phil Hass is going to come up and talk about testing for multiplayer games based on his game Galcon. So we'll try to transition quickly. But we're still going to have about 5 minutes for questions after each of the sessions. Okay, so as I said, this is going to be about mixing UIKit and OpenGL, and we only really have 25 minutes, so it's going to be pretty quick. I'll have the slides and some sample code on my website, so don't worry about trying to catch every bit of source code that you see in there. There'll be some slides, so it's just no way you can write it down, or I guess you can take a picture. So let's just get started. The first thing is just quickly about me. You can just go to my website and read about it. But the important thing is that last year I released Flower Garden, which is not a chart topper by any means, stretch of the imagination. But one of the things that it does is it does really mix a lot of OpenGL and UIKit, and I think that's something that not many games out there are doing. And obviously, I'm giving this talk because I think it's a very useful thing to do. It can save you a lot of time and has a lot of benefits. And before that, I was in the games industry for many years. So I guess that just gives me a different viewpoint coming to iPhone development. Okay, so let's just talk about OpenGL and UIKit. Why do you want to mix the two? Well, obviously, you all know this is the GDC, so you all know that OpenGL is great for 3D graphics and really high performance things. So of course, I have to put a teapot, but you can do much more interesting things like something like this. So that's why you want to do OpenGL. So really the main question that we need to answer is, why do you want to use UIKit? Right? So what exactly is UIKit? UIKit is a layer that it's available in the Apple iPhone SDK. And it gives you user interface elements. So those are a bunch of the user interface elements that you get. You get everything from buttons, labels, to something fancier like those pickers that slide. I mean, you're all familiar with this. But it gives you more than that. UIKit gives you transitions as well. So, the cute page flip transition, or the curl up, or the sliding in and out, and all those little curves for the animation. And it gives you even more than that. It gives you a great tool, Interface Builder. Can I see a show of hands? Who here has used Interface Builder? Wow, okay, great. That's more than half of the people. I know a lot of people are kind of, I'm not going to say scared, but it's like, especially as game developers, they're like, no, I'm not interested in Interface Builder. It really is a great tool once you get the hang of it. And if you're using UIKit, you get to use Interface Builder, and it's a great time saver, something that you might have to write yourself otherwise. So what are the advantages of using UIKit? Obviously, you have lots of save time because you have all this behavior that is already implemented for you. And it's not just that it's already implemented, but it's already the users are already familiar with it because they're already familiar using other iPhone applications. So that's a big win. They're familiar exactly how the scroll views feel. You don't have to re-implement the scroll view and all these little bouncy things. I mean, I've had to sort of re-implement some of those things, and I know how much of a pain it is. I mean, even doing a button that works well, it's a pain. A lot of people, a lot of games will re-implement their buttons, and they'll click when you push them, not when you release them, for example, which is not what you want in a user interface in the front end, especially in something like the iPhone that doesn't have a physical button. You really want to wait until you left it. So reusing the behavior that UIKit gives you, it gives you maybe a lot more than you may think at the beginning until you start implementing it yourself. And you'll go, ooh, yeah, that's a lot more complicated than I thought. And UIKit is actually, it gives you a pretty good performance. It is hardware accelerated. It does use OpenGL under the hood. And sort of like the way that the UIKit works is, it definitely, it renders an image or does whatever with an image, and then it's sort of you can think of it as in video memory, and then you can move it around, all hardware accelerated. So the performance is pretty good. Don't think that it's not like Quartz 2D, that it's all CPU pixel by pixel. You can do a lot of things with UIKit. So when would you not use, or what would be some of the reasons not to use UIKit? There are a lot of games that are not using it. Why would that be? Some people might say Objective-C is a reason not to use it. They're not familiar with Objective-C, so UIKit is all in Objective-C, like most of the iPhone SDK. And some people maybe coming from C++ background, they're like, I don't want to deal with it. I'd say don't let that be an argument. I didn't know a single thing about Objective-C about a year and a half ago, and really, it's like 2 days to get up and running, and just in like 2 weeks, like everything there is to know about it. And it's really a great language for all the sort of user interface, I think. Maybe not so much for high performance, like I wouldn't be coding my inner loops of my games with Objective-C, but for front-end stuff, it's great to work with. And the best thing about it is that it's a dream come true for interop with C and C++. I mean, if you ever try to do C# development, you know that going back and forth in C# and C++, it's a total pain. With Objective-C, it's just like seamless. You call both ways without a problem. So it's really great to work with it that way. And I guess a more important reason maybe why you might not want to use UIKit is it's not that portable. I mean, now the range of platforms is quite a bit. So you have iPhone, you have iPod Touch, you have iPad, and you have even Mac OS. Windows a little different. But you can target Windows, Xbox, web games, all those things. So, and then maybe another more important reason as a game developer is that you don't have as much control over performance and over memory as you would with OpenGL directly. Sometimes you don't know exactly when is this image going to really be loaded in video memory. And sometimes it happens at the worst possible time, when you want to display it or when you're in the middle of an animation as opposed to pre-caching ahead of time, things like that. But again, for maybe front-end kind of things, it's totally acceptable, and the benefits, clearly I'm giving this talk, so I think the benefits outweigh the potential drawbacks. So, and I guess maybe because of the performance things is one of the reasons that maybe more casual games tend to use UIKit, and it's more like high performance hardcore games tend to use OpenGL. So our games right now using UIKit, if you go and browse at the App Store, have you seen UIKit games? Probably many more games than you think. It doesn't mean that because it's using UIKit, you're going to see the standard buttons, that you can pretty much reskin almost everything. You can put, UI images and stuff. I'm not going to go one by one on which game is using which, but if you look at it, I find, and this is totally, it's not like I want to measure it, but I find that they tend to cluster. You find a group of games that is using UIKit, and as I said before, those tend to be more games that tend to be more casual games. And, some of them are very popular. Probably a lot of you have heard of Scoops. Is Ian here? Yes, so Scoops, Nimblebit. So it's all made with UIKit. You couldn't tell when you play the game. So it's great. And then you look, and there's another whole cluster of games that is using OpenGL. And those tend to be more, they go for flashy graphics. Obviously, if you're going to do anything in 3D, you're pretty much forced to use OpenGL. But even 2D, Space Miner, Field Runners, they'll be using OpenGL. So what I'm addressing here is the middle. The middle, I really think there's an opportunity to make games that give you the fast development time and the great tools that you can use with UIKit and combine them with the performance of OpenGL. And if you do that, you can really get the best of both worlds. And if you don't get that, you need to go back and watch some Star Trek. So what are we going to see today? We're really going to go through some sort of use cases that I did in Flower Garden that I think are interesting, sort of from simpler to more and more complicated. So we're going to see, really quickly, how do we get OpenGL on the screen, which we need as a basis, and then we'll start, which that's kind of like what every game does, right? And then we'll go, well, what if you want to only display part of the screen? What if you want to add UIKit elements on top? How do we do animations on the OpenGL view? And I don't mean inside OpenGL, but like page transitions, things like that. How do you deal with multiple OpenGL views? Landscape orientation. And then the last two are transferring content between OpenGL to UIKit and from UIKit to OpenGL. So the basics. Displaying OpenGL graphics. You can go you can go right now to the Apple dev site and download the, what is this called? The GL Gravity sample or something like this. And it's just a perfect skeleton that sets up an application that renders OpenGL graphics for you. So it's a good example to start from. If you look at it, you realize that what's being displayed on the screen, that's just a view. It's something that inherits from UI view. And specifically, right, so it inherits from UI view. And the magic that allows it to display 3D graphics comes in that EAGL context. And in that method that uses a specific layer that pretty much hooks that view to the output of whatever comes out of OpenGL. And then on your end, well, I mean, this is still your end, but on the OpenGL end, all you have to do is set up your render buffer to use that context. And once you do that, bang, you have a full screen OpenGL display. So that's the basics. And the really key thing is to realize that ultimately, that OpenGL view is just a UI view. So almost anything that you can do with a regular UI view, you can do with it. Actually, I'll take it back. Everything you can do with a UI view, you can do with it. There's some things that you might not want to do because maybe performance is not the greatest, but you can still think of it from that point of view. And as soon as you think of that, then it starts making sense how you can do a lot of the other things that we're going to be talking about. So, for example, how do we display something that is not full screen? So as gamers, we're used to full screen games, and a lot of it's just because of the immersion, whether it's on TV or just it's your phone. It makes sense. You want to do the biggest graphics you can. But also traditionally in some platform, I'm thinking of Windows like 10 years ago, it was actually faster to render full screen than it was in a window. Fortunately, that's not the case anymore. But you don't always want to take over the whole screen. And this is one screenshot from Flower Garden, in which it's only the top of the screen that would displays the flowers. That is all in OpenGL. But the bottom part is just your standard UI tab. So this is a view derived from UI view that has the EAGL context, but the size is smaller than that. So I set it up in Interface Builder. I mean, there wasn't that much to it, but I set it up there anyway. I'm not sure you can really see it, but the point is it's set up in Interface Builder, and the size is different. So the size for this one is 320, 431 instead of 480. And really, all you have to do is set up your correct projection matrix and your correct viewport. And there's nothing else to it. Now you have an OpenGL view that takes however much you want of the screen. Now, it has to be, rectangular edges. You can't have any weird, cutouts or anything like that. So if you want to have something that it's not a rectangle for your view, you need to superimpose something else on top and be careful with that. But that's very simple. Performance will be perfect. There's no drawback as far as I can see from only using part of the screen. So you're always free to do that. Okay. Getting progressively more interesting. Now let's add UIKit elements on top of the OpenGL view. So that was an example that I put the UIKit elements underneath because I didn't need to put them on top. Let's add them on top. And the things are they're just subviews. The OpenGL view is just UI view, so you can call add subview and put anything in there. Now, there used to be in the documentation, if you were doing iPhone development with the SDK 2 or 2.1 to 2, whatever, there used to be some warnings in the doc saying, be careful putting UIKit elements on top of OpenGL views. Definitely discourage you for, and I think, I don't know, unfortunately I don't have the exact sentence in there, but something about performance and possible instability. I've never seen the instability part, but definitely there were some performance issues. And the reason for that is that if you put something on top, so we start with our OpenGL view in there, and we add maybe a couple of views there, and then we add a little label in there, the system needs to compose your image, right? Now you have all these images, and it needs to compose it. And UIKit really is designed, like we were talking about earlier, it's really designed to respond to events. So it's more like it does a little something, and then it just stops, static, it waits for you to do something. Chances are your OpenGL view is going to be driven by a game loop, and it's going to be updated and rendered 30, 60 times per second, which is not exactly what UIKit, it's sort of like the default use for it. So how those images get composed could cause a problem. It could cause redraw of the other images and all those things. So it used to be particularly bad in 2.0, especially when you were doing the main loop update with NS Timer. Now in the current SDK, that is much better. So that's really good news. You can definitely put elements on top of an OpenGL view without much of a problem. And it seems to be particularly good if you're using CA display length to drive your main loop, like you should anyway. And I don't know what is happening internally, but I suspect that because you're using CA display length, it gives more information to the system about when the updates happen, and it can coordinate things better. Whether NS Timer, it never knew when you were going to render something. So, but in any case, the good news is that you can definitely layer UIKit elements on top of OpenGL without going crazy. So If you're going to put something really complex, you might want to consider stopping the update and render of your OpenGL view. You can still leave it there. That's okay. Because this is not like maybe a game on a console or on a PC that if you stop rendering your screen every frame, then it's just going to go blank because you're clearing it. The image is going to stay there until you do another render. So if you want to put something on top, like a big pause menu or like a big high score menu that is not important to be updating your animations of your game in the background, you can just stop the animating and the rendering, and then just all the layers are just going to stay there with a static image at no performance cost to you. So my recommendations is avoid really sort of complicated hierarchies on top of OpenGL, and avoid large transparent objects. Alpha blending is always sort of an issue with the iPhone, especially with the 3G. So you don't want to have a huge UIKit thing that is lots of transparent pixels. And also actually avoid, one thing that I find is avoid UIKit elements that are changing very much. They're changing a lot. Like I had in one of my projects, I was using a UI label to display the score. And in this weird game, actually, every frame your score was going up. Pretty much like every frame that you were alive, almost like your score was going up. And because that label was changing, it must have been triggering some redraw or something in that hierarchy. And it was definitely causing a hit in performance. Now, it wasn't a huge hit, but it was enough that before I was a rock solid 60, and that was dropping me down to 30 because I was using the CA display link. So, in that particular case, for that situation, I had to say, well, okay, I had to use my own font rendering for that, and back to 60. So watch out. But other than that, you can definitely use it for buttons, labels, solid views. Obviously keep an eye on performance, but it's totally solid. Okay, animating an OpenGL view. This is really easy, just like any other view. You can do the usual begin animation, and you can slide it around. You can animate the position. You can do the usual page flip transitions, all those things. The only thing is that animating a full OpenGL view, if you're updating and rendering it, plus the animation going on, it can definitely cause some hiccups in performance. So again, I find that it works better if you can stop updating your own OpenGL view while this animation is happening, and you get a much smoother. If you can get away with it, you can get a much smoother animation. Maybe like at the beginning of the level, you can bring in you render it once, animate the level in, and then start animating the level. So because really when you're bringing it in, probably nothing is happening. So if you can do it, you'll get a much better result. So yeah, that's what I said. Okay, now this is where it gets really interesting. Using multiple OpenGL views, and why would you want to use multiple OpenGL views? To be fair, most games they can get away with a single OpenGL view. They have a main game view, and that's all they need. But sometimes you need more than that. For example, imagine you're having some sort of RPG game. Clearly, you're walking around the world view. That would be an OpenGL view. But then maybe in your front end, you want to customize your character, and you want to see your character in 3D and all that. You probably want to render that in OpenGL and see the changes as you're changing your hair color or whatever. So that might be a good use for a separate OpenGL view. Sometimes you might even have two OpenGL views in the same screen. I haven't done that, but you could do that. And sometimes you might even want to transition between the two and things like that. So how would you do that? There are multiple ways that I found that you can go about it. One of them that I didn't go down that path is you could use different OpenGL contexts, but it really prevented reusing of assets that were created, like textures that were created with one context into the other view and all that. So what I found the most straightforward way was to use one render target per view. So we're going to see it in a second, I think. Right. So really having multiple render targets is something that is a really useful thing that you want to have in your game anyway. That way you can render the scene to an off-screen buffer and then maybe do some processing in it or use it as an environment map or something. So once you're set up that way, you can totally create a new render target with each view's EAGL context that I showed you at the very beginning. And then all you do is whenever you display the view, you just bind the render buffer that you created with that one. And then bang, the output of whatever you render goes to that view. And you can do that either as you switch to, at the beginning of the render, whenever you're going to start rendering the scene, you can switch to that. Or if you're never rendering at the same time, you can only switch maybe when you get the view will appear call. That's what I do right now. And that works great. And you can definitely destroy one and then recreate it later if you want to do that, so you don't have your front end always loaded in memory. That works really well. Okay, landscape orientation. This one can be a little tricky. You'd be tempted to just treat it like if it were not an OpenGL view. And that would be, so you just rotate something at the root and you have some sort of hierarchy, and you let the OpenGL just be rotated because the transform propagates on the hierarchy. That actually works if you try it. But to be fair, I haven't measured the performance, but Apple recommends against it for performance reasons. So, you probably, the OpenGL view is pretty sensitive to that, so you don't want to be adding the extra transform. So instead, the recommendation is that you transform it yourself. So you leave it in landscape mode, but you can just rotate your projection by 90 degrees. So it would look like it's, let me just go back. So yeah, you just rotate your projection by 90 degrees, and so it would look like it's in portrait mode. But if you do that, you can't leave your OpenGL view in its normal place in the hierarchy, because then it's going to be doubly rotated, right? You're rotating the transform, the projection, and you get the transform from the hierarchy. So in that case, you want to put the OpenGL view at the root. So you want to have something more like this. You just leave it in landscape, you rotate the projection, and you let everything else propagate from that. There's a lot more to the story, as Owen can tell you, and I'm sure he'll be writing that more in his blog. But apparently there's some tricky things if you combine this with a navigation controller. So you can Google for that. I'm not going to get into details. Okay, 2 more cases that I want to talk about, which is how to transfer data back and forth. And that's sort of going to complete our full integration. I mean, once we know how to do those things, like perfect integration of OpenGL and UIKit. So why would you want to transfer data from OpenGL to UIKit? And that's anytime you want to do something with what you've rendered in OpenGL other than just display it on the screen. That's sort of the default. But maybe you want to take a screenshot of what you save, what you rendered, and save it to disk. So maybe you can send it as an email or upload it to Facebook. Or maybe you want to render something and then take sort of like a snapshot of what you render in 3D and update it to the UI element in UIKit. For example, in the character customization thing that we're talking about, maybe you get your red hair barbarian, and then before you move out of that screen, you take a little screenshot and you put it in a button. And now you have some other screen that is purely 2D, but it has an exact render of your barbarian that people can tap on it, and then it brings you to the character customization screen. So that allows you not to put the full 3D rendering right there. So it can be really useful. And in the case of Flower Garden, I actually do it in 2 different places. One of them is, you put this bouquet and then you email the result of the bouquet. That's creating a UI image from OpenGL. And then the other one is that when you're taking care of the plants or whatever, and then you switch to this screen, this overview screen, each of those buttons are an actual render of the flowers from top down. That's never shown on the screen. It's just I do that off screen to an off screen buffer and then take those pixels and update the UI image for those buttons. And how do you do that? The easy part is getting the pixels out of OpenGL. You just do GL read pixels. You need to be careful with the you want to avoid as much color conversion and all that as possible, but it's pretty much that one line. Read pixels, give it buffer, bang, you have them there. The tricky part is actually stuffing those pixels into a UI image. And I don't expect you to even read that right now, but you can look at the slides online. Primarily, there are 2 things going on in there. There's the color conversion space going on, and then there's a vertical flip. But yeah, that's the tricky part. But once you do that, you have a UI image, and then from there you can go anywhere. You can stuff it in a button. You can do save, as JPEG. You can do whatever you want. GL read pixels is slow, so watch out. This is not something you want to be doing every frame. So, in the case of the overview in Flower Garden, I'm very careful when I update those buttons. I actually do it every time you move out of one pot. Instead of doing them all at the same time when you go in that view, I do them one at a time when you move out of them. So, it's a few milliseconds hit for sure. And it also depends obviously how big the buffer is. And then the other thing to watch out for is the amount of temporary memory that you're going to need to do this. You're actually going to need 2 temporary buffers that are as big as your image. So you're going to need the UI image that you're creating and 2 temporary buffers along the way. So it can definitely be an issue, especially if you use it to take screenshots that are larger than screen resolution, which is something you can totally do. You can make a frame buffer that is 1024x768, iPad resolution, and do a render to that, and then save it to disk. And maybe you want to do this so you can look pretty, or maybe you can downscale it and get some aliasing that way. I mean, the sky's the limit in what you can do, but it's going to cost you a lot of memory. So just watch out for that. Okay, last case is rendering from UIKit into OpenGL. And why would you want to do that? Well, there'll be whenever you've created something that you have in a UI image or in a CG context that you actually want to put in a texture in OpenGL and then somehow use it. So you can do all sort of maybe crazy things with it, but an obvious one would be font rendering. OpenGL is notorious for lack of font rendering. And UIKit has some decent things, and the latest SDK has some really good font rendering functionality in it. So you could take that and upload it to a texture and then use it with OpenGL. You could even use Quartz 2D, which is like the sort of the CPU pixel API that you can do cute curves and then alias things and paths and masks. Compose your image and bang, send it to OpenGL and then use that in OpenGL. So there's a lot of potential there. So the trick is once you have a UI image, you actually do the opposite conversion to what we did before. And you upload it to a texture, and like a lot of you are already going from a UI image to a texture. You already know how to do that. So it's actually this is the easiest path. The only thing that I want to highlight in here is that you can actually have non-32-bit textures, and you can do special things. For example, here's a function that I use to print text directly into an OpenGL texture. And because it's just text, and in this case I'm saying it's just going to be grayscale, I use an 8-bit grayscale texture. So I'm saving lots of memory this way. So it can be really handy. So I use this for the bouquet tag. So last thing is just want to show you how this is all put together. And I've been talking about Flower Garden. So this is like a quick video that shows a bunch of things. It shows what I said earlier. Top one is OpenGL. Bottom one is UIKit. Got you there. We're going to have UIKit elements sliding on top and animating. Obviously, we'll take a screenshot of this and then send it out. So there's the OpenGL to UIKit. It's also going to be interesting that as soon as I start this animation, we're going to slide into UIKit. At this point, now everything is UIKit. We're going to type some text, and then we're going to take that text, put it into an OpenGL texture, and now we're back in OpenGL. And the thing that I'm particularly proud of here is that transition is totally smooth. But at one point, it actually jumps from that label. It's all OpenGL. Now it's all UIKit. And now it's just like a multi-text field. So if you're careful how you do it, you can get some pretty seamless transitions going on. Which I think is really powerful given the benefit of that. So conclusions, really quickly, because we're pretty much out of time. I think it's really powerful to mix the two. You can save a lot of time and reuse a lot of code and get some very familiar user interface. It saves you a lot of time. It gives you access to great tools. Really learn and appreciate Interface Builder. For my latest project, I'm actually using, believe it or not, it's very simple, but I'm using Interface Builder as a level layout tool. It's kind of cool. I'm not using it to make the thing you're going to see. I'm using it to just lay out things and then using the information of where you lay out things in the game. So it's a lot more than meets the eye. And that's it. Thank you very much. So that's my website. The slides will be there probably tonight. And the dog ate my laptop, so I wasn't able to put source code up there yet. So maybe in like a week or so, I'll have a full demo showing all these cases in a simple application that you can run. So while Phil gets set up, are there any questions?
You mentioned there's a catch with using it with a UI navigation controller with the transform and the GL view. Do you have any more details on that, or?
So Owen, raise your hand over there. Everybody should go talk to Owen. But pretty much, there's some weird things about like when you put it in, like it loses the rotation, and just talk to Owen, and he's going to put in a blog post. So it seems like it's a tricky case with that one. Any other questions? Just go up to the microphone. No? Okay, well, I'm going to be around, and I'll be around at the social gathering thing at the end of the day. So if you see me there, just come by and ask me anything. Thanks again.